I'm Ryan Grove. This is my wife, Tiffany Grove. We're having a conversation about the flat earth. And the reason we're having a conversation is because we're not having a debate, because both of our experiences on various issues on the internet have shown us the frustrating, endless round and round and round that you can go with a debate, especially if we're not technicians or scientists or experts. We're just laymen, try to filter information as it comes in using our sieve of logic and intuition as our guide. That we're both just trying to understand our world a little better. Although it may have turned into a debate with her because she has all of these notes. And of course, I'm going to go organic with this and try to keep it as conversational as possible. Now, we did say that we're going to talk about eclipses next and Foucault's pendulum, which I kind of regret now because those seems to be tangents that are more peripheral than integral issues that determine the actual cosmological shape of our world. So, in light of eclipses, like I said, I don't have much to say, but maybe I can get you started. I have been exposed to information through my research that indicates that in the last 500 or 600 years, there have been at least 50 recorded eclipses where the sun and the moon are both visible above the horizon. So, have at her.
Okay, so I guess first I would just say that my only reason for notes is because it's been a long time since I've ever had to talk about anything to do with
Eclipses?
geology or cosmology
I know,
or
right? I think a lot of us are in that
weather
same boat.
patterns or
Me too. I find myself floundering a bit too
inertial frames or
from
things
time
like
to
that.
time.
So I guess I just wanted to kind of address something that you were talking about yesterday, which was when I asked you, how do the seasons, or just kind of how does your flat Earth model work? You were saying that was, a flat plane disk, and that you thought that the celestial bodies moved overhead in the dome. Yes?
The stars, yes.
And you said something about it spirals in towards the Tropic of Cancer
And spirals out
and
to
Capricorn.
Capricorn.
Right. And that would explain
the seasons.
So, but what I think about that is like if you just kind of put it up to like just kind of a testable, repeatable, or is it predictable? Does the data turn out if the Earth was like that, and that's how? So
that seems reasonable if I understand what you're saying.
So, the sun on your model, the sun would have to move at different speeds.
Yes.
Either summer would be shorter than the winter otherwise, and for day and night you have to make the sun making arbitrary straight lines across the middle of a flat surface delineating day and night. There's some arbitrary line where the sun, just the rays of the sun, don't
arbitrary line. It's
anymore or reach anymore.
It's the reason if you go into a dark cavern with a flashlight, you point the flashlight and it lights up, but the light diffuses the bigger the space. And so
day and night, day or night.
Day and night is simply
it's
caused.
Not like some diffusion of day and night at some point.
Well, what's twilight? What's daybreak?
No, I'm saying
those are diffusion periods in this path that's being taken by the sun. And so twilight and dusk, like I just said, would be diffusion points of when this lantern comes into proximity, and then it disappears and leaves.
And then your model has the sun and the earth, the sun and the moon on opposite sides.
Sometimes, but that's always changing because they are moving at different speeds as far as I understand it. And it's this
sometimes you can see them together.
But sometimes you can see them together, of course, and sometimes you cannot. Okay. Sometimes you can't.
Obviously. But the problem with that model, like according to how my model works, the sun's rays, which are almost perfectly parallel, strike Earth at different angles during different parts of the year. And if the Earth were flat, the sun's rays would always come in at the same angle, meaning that the USA, Australia, Italy, and Argentina would all experience the seasons the exact same, but actually, in the summer in the US, it's winter in Australia.
Right.
And Italy's winter lines up. But this is because of the Earth's tilt.
Right, I understand
it's
that.
It's at a 23.5
What about
degree
corpuscular
angle
rays?
relative to the sun.
When the sun moves over a cloud, or you see a sun.
So the northern hemisphere is tilted toward the sun for 6 months, while the southern hemisphere is tilted away, and vice versa. Consequently, while equatorial areas receive direct sunlight all year round, polar areas spend half of the year pointed away from the sun. But according to your model, and also the Earth's tilt explains the extreme length of day and night at the polar locations, while the length of day at equator is nearly equal to the length of the night. And
that can be explained in my model too.
No, it can't.
Well, it can, because as it's transitioning from the Tropic of Cancer to the Tropic of Capricorn, it seems like extreme.
We know that the sun doesn't change speeds. We know that.
It seems actually, we don't.
Yes, we do.
But we digress. Actually, we don't.
Okay.
And what I would like to say is that the reason that it seems pretty equal at the equator is because, as I said before, the sun, as it transitions from Cancer to Capricorn, it's spending little time with each severe polarity.
But it's not.
However, it's spending most of its time at transitioning back and forth across the equator, and there it would be most visible, and it would have it would give off the most heat consistently.
But it's not that simple, because actually the warmest spot is up here. It's away from the equator. It's like the Death Valley or whatever.
Well, maybe that has to do with elevation. And it's closer to the sun.
Okay, guess what?
Maybe. That's just a guess. I have no idea.
When you go up, it gets colder. And according to your theory, it should get warmer. If the sun were actually as close as you're purporting, then the higher of elevation you get, the warmer it should get.
Well, you're talking about mountains, though. You're talking about mountains, which are severe elevations, higher elevations. I'm just talking about just like from a plateau or a steppe versus like a deep valley. Geological. I mean, obviously, mountain would be geological, but I mean,
in a depression, yeah.
That's right. Maybe at that level. I don't know. Yeah. I'm just saying. I've never been arrested.
Yes, he's safe around the children.
Before I was a flat earther, I was never arrested. I was a father of 6 kids. I was an artist and a waiter, and I've never been arrested. And after becoming a flat earther, I am a father of 6. Been an artist and a waiter, and I've never been arrested. And there's nothing different. So just because I adopt and embrace these things, first of all, I would like to establish that it doesn't necessarily indicate that I have some mental deficiency or something like that. Nor does it meant to indicate that I've gone through some transition into madness.
You've done a lot of paintings. You're an artist.
Yeah, I'm the same either way.
You're not a scientist. We know.
Right. And also, something I would like to highlight
I'm not a scientist.
Is that weather? Exactly. That's the whole point, because most of us aren't out in the world. And so when we're in that position, then what we have is a belief system, just like religion is a belief system. This is a belief system because you are trusting the conclusions by other people,
although there are tangible
who have
aspects of this belief system that
claimed to have done experiments,
predictability,
and
repeatability.
Yes, and we trust them.
Of course.
And in order to trust somebody, you have to have faith in them. So. And in light of the fact that you can't really prove anything, whether you believe in any cosmological reality versus another, it's simply a belief system, because we're not out there going up in space and looking down. We're just listening to other people's tales.
But scientists don't eschew faith. I mean,
we use the same mechanisms to come to the one conclusion as we do to the other. We just listen and we do. We calculate and we assess,
Richard
and then we come to a conclusion.
Who's a professed agnostic.
Yeah, the
pleasure of finding things
pleasure
out.
Of finding things out.
Yeah, book, the pleasure of
finding the nuclear bomb and all that stuff. Yes.
Well, he says that yes, that every above the hulls. Oh, I hope I'm not mixing his quote up with Planck, but they both say something about
Hey,
faith.
if
But
it were
I'm
debate,
sorry,
you'd have to have that quote. If it's a conversation,
Yeah.
you can just gist it.
No,
'cause we're
I
just talking.
actually was going to have the quote. I was just too lazy to pull it out
All right.
today.
Well, if we were in a bar
But-
talking, you wouldn't be worried that you didn't have the
But
notes. So.
you know, Feynman does say, yeah, you know, every scientific endeavor is a leap of faith. But there's a difference in
Not
like
just
the kind of
scientific
faith without fruit, and then there's the faith where you have faith in an experiment that you're excited about, you believe in it, you pursue it, but it's a disinterested faith because you know you're willing to realize that it was wrong if it doesn't work out scientifically.
I think
It doesn't meet the standards of the rigor of the scientific method, which is a real simple thing. It's not.
Well, can you apply that standard? I mean, have you applied that standard to all of these issues and have been loyal to the scientific method and hypothesized
I will tell you
conclusions?
that I do have enough faith in people to believe that they have.
And so at the end of the day, it's just a faith. It's just a.
No, it's not, because
it's faith.
It's
a belief
weighed
system
out by experiments and data.
Okay.
So it's not the same.
All right. So what do you have to say about eclipses then? Because all I can say is what I said initially to get you to go. So do you have anything that you think is useful and valuable to contribute about?
So you've
eclipses?
said that on your flat Earth model with the dome, heavens or firmament or heavens, that there are times somehow when the sun and the moon are gonna meet up together on their. But I would say that if you go to the North Pole, I mean, well, first of all, you got rid of the South Pole, didn't you?
Yeah,
in your model,
of course.
So then, how would you explain that how different stars are visible from different latitudes in the night sky from a high northern altitude?
Okay.
Latitude location. You'll see the big Little Dipper, bright orange giant Arcturus, and the
I'm going to look stupid. I'm going to look stupid on this.
If you view them from the South Pole, none of those are visible, but you can see Alpha Centauri, the Magellanic Clouds, and the Southern Cross, and none of these are ever visible to most Northern Hemisphere sky watchers. And if you are in Cape Town, Africa, South Africa in the Southern Hemisphere, or Melbourne, Australia, you cannot see the North Star. So,
which would make a lot of sense in my model, just because the North Star, especially if the stars are at a dome, is super far away. Is as far, pretty far away. Second of all, there's another concentric movement that I haven't. It's going to make me seem stupid. Is that I think that the whole firmament is also moving. It's very, very slow.
I asked you, was the firmament moving? And you said no, because it's fixed on 4 pillars.
Well, I don't remember. No, you asked me if the Earth was moving, not the firmament. And I said, no, the Earth was not moving because it's according
What's the firmament?
To the Bible. It's a dome.
Oh, okay.
Yeah.
I don't know why I was thinking firm ground.
If we get into a Bible discussion about it, I'll have better reasons, but of course none of them will make sense unless somebody else also believes the Bible is the same kind of authority that I believe it is. But that's neither here nor there.
Okay, so there's no South Pole in your model, but what I'm asking you is then why the different perspective? Where are you at on your map?
In Illinois. In my house.
No, if you're at the South Pole.
Yeah.
Where is that in your map?
There is no South Pole. Middle? No, it's a parameter.
The edge by the Antarctic ice wall.
Yeah, it's anywhere along because in a circle, if you have a center point, every point on the parameter is out and away. It's the opposite of the point. So no matter where you're at. I mean, but of course, then it's silly to ask where would the South Pole be on that because the pole wouldn't exist.
Okay, but I'm just saying.
She's laughing at me.
if you were standing
It's a hard pill to swallow.
at the South Pole and you couldn't see the North Star, okay,
There is no
where
South
is
Pole.
Cape Town, South Africa?
It's at the very tip of South Africa.
In your round map, where's that?
Maybe we should move on. Let's take Foucault's pendulum.
Okay.
I don't think this is all that fruitful. Just what we're talking. So the pendulum swings. The pendulum swings, and that means that the Earth is spinning.
Okay.
Is that correct?
Well,
unleash the Kraken, my dear.
Let's talk about it a little bit better.
Okay.
Oh my goodness! I just have to
wipe your teary eyes.
You know, just sometimes you get nervous and it makes you laugh, I guess.
Okay.
So, what Foucault's pendulum posits to do is prove the rotation of the Earth. And you can see a few good ones. One is at the Deutsche Museum in Munich.
You can see some really really beautiful ones, expensive, elaborate ones. You sure can.
Foucault's pendulum, at either the North Pole or South Pole, the plane of oscillation of a pendulum remains fixed relative to the distant masses of the universe, while Earth rotates underneath it, taking one sidereal day to complete a rotation. So relative to Earth, the plane of the oscillation of a pendulum at the North Pole, viewed from above, undergoes a full clockwise rotation during a day, and a pendulum at the South Pole rotates counterclockwise. Yes. And when Foucault's pendulum is suspended at the equator, the plane of oscillation remains fixed relative to Earth. At other latitudes, the plane of oscillation precesses relative to the Earth, but more slowly than at the pole. The angular speed, with measured in clockwise degrees per sidereal day, is proportional to the sine of the latitude y. W equals 360 degrees sine. And that sine, I forget what it is. It's like a Y shape divided by a day. But it's just trigonometry, where latitude north and south of the equator are defined as positive and negative respectively. So they balance out. Does that make sense?
Mm-hmm.
Depending on where the pendulum is put. And a Foucault pendulum at 30 degrees south latitude, viewed from above by an earthbound observer, again, viewed from above, rotates counterclockwise 360 degrees in 2 days. And so it's showing us simply the rotation of the Earth. And it's very accurate at the different positions.
Okay. I'm glad we got through those.
Okay, so what do you have to say about that?
That I think that is just silly nonsense. Mm-hmm. That's just my opinion. That's what I think.
Why do you think it's silly nonsense?
I think that well,
because some guy tried to build.
Well, no, hey, maybe there shouldn't be a.
But it has to be very large. It's very, very
precise.
Okay,
all right. I saw a documentary, and I forget the museum, and in the museum was a Foucault's pendulum, and the docent was talking all about this, basically the same things that you're saying, but throughout she admitted that they have a motor that keeps it swinging all the time.
Sometimes.
Well, second of all, if this were true, then wouldn't you think that there would never be a stationary pendulum on the planet anywhere at any time if it's a real pendulum?
There probably isn't a stationary pendulum unless it's set in a vacuum.
Okay, that's we're just putting that out there. So, whatever. All right. I this is kind of lame, but this is such a big issue, and that if you want to teach a kid calculus or something like that, you don't just start in with the big stuff that you get to at the end, nor do you teach it to them in a day. It's got to be precept upon precept upon precept. Right. So in that spirit, I may seem to be roundaboutly avoiding the issue, but I'm so worried about the reasons why I consider the Earth to be flat. I'm so worried that those reasons are going to be misunderstood because an improper foundation has been established.
Well,
so to continue, and I was doing that last night, but to continue on my part, this may seem unrelated, but now that I'm free of eclipses and Foucault's pendulum, perhaps we can get to something more interesting, eventually.
Okay.
Is that a part of this setup of mine to get me to a place where I could consider the possibility the Earth is flat is that I don't think that ancient civilizations were as dumb and backward. I don't believe in the timeline where we went from standing up in the grass to living in caves to doing the stones first. And there's so much evidence, and then leading up to technology, and that according to that paradigm, that our present modern day generation should wear the crown of being the most technologically advanced, the most philosophically advanced, because of all the how I understand history is that from the very beginning, civilizations demonstrated architectural capabilities and understanding of astrology and the movement of the stars to such a degree that it's mind-blowing even today. And there's even been hints and pieces and relics of that may indicate that they had some technology that was pretty awesome. So my understanding is that men, the way I see it, it's not this linear gradual maturation of technological advancements and arts, etc. What I see it as is, for some reason, people get it, and then they misuse it, and then they're destroyed. And then we go through this dark age, and then it happens over and over and over and over again. And I think faulty historians take the moments where it collapses and finds evidence of people living in caves or people using this sort of primitive technology, and it strings along its narrative for history, using those pockets and ignoring some of these other moments. And that's just a basic overview of how I perceive history. And that
the dark age of
changes.
All right. In the BC period that we're
sure. And even before, and even it can't be before the BC period, but before any civilization you're talking about, I'm sure that there's ones that have preceded it, like the arithmetic and the astrology and the of the Phoenicians, or even the Assyrians, and of course the Egyptians. It's astonishing. A lot of those things that they did, we can't do today.
That actually started in Babylon.
So if history isn't put together in this linear, gradual crescendo of human achievement, but it's in this weird cyclical pattern of greatness and falling over and over again, then I have more credibility that I can give to the discoveries and the myths and the folk tales of ancient people. I can take them more seriously that way than the modern man can't, because just by rights, the modern man is at this point of that just transcends what any of these primitive cultures could have come up with, and that indirectly diminishes immediately any credibility from the tales, from the remnants of their culture, society, and their observations. And in that light, a lot of these civilizations had elaborate, well thought out versions of our cosmology that weren't just mythologically described to their culture, so that people, because you need symbols, right, to understand truth, especially abstract truth. You got to have symbols. And so there's more to it than just the myths they used. I think that you have to acknowledge the fact that they achieved certain intellectual heights, and maybe that may have even surpassed what we're aware of today. I talked a long time, so you.
Okay, so I would point out that I think another thing that shows that the Earth is a globe is the presence of Schumann resonance. Because
what, would you describe that?
Well, it was discovered by Winifred Otto Schumann, and his major was physics of electricity, or that was his major part of his research. And a sphere within a sphere can create electrical tension and subsequently a frequency, which is called Schumann resonance.
Gyroscopes are loosely based on that. So, okay.
So it's kind of like the pulse of our planet. It matches up with the alpha waves in our brain.
Sure.
But that's created by the sphere within a sphere, that electrical tension.
So what is your application then to this topic using that?
Well, it just shows that if we predicted that the Earth was a globe, and so we state that the Earth is a globe, so one of our predictions is that we might find evidence of that somehow. And one of those evidences would be that if we have our ionosphere like we think we do, and we have our
if we have
Earth,
our eye on a sphere, or do you mean an ionosphere?
An ionosphere.
Oh, okay.
And the Earth, so according to what we think the Earth looks like, then there should be some kind of electrical tension between the ionosphere and the Earth, if it were a globe, because it's somewhat a closed
And we've
system.
done that? We've discovered that then? Because I don't know anything about
the
this.
Schumann resonance, yeah.
The resonance itself.
If you're underground and you are deprived from the Schumann resonance, they did research, and it makes people lethargic. I'm not sure why.
Well, we got 4 minutes left, so I'm gonna look up
Schumann resonance.
Yeah, okay. And maybe sometime I'll have something to say about that. We're no longer gonna predict what our next topic is gonna be, because
that puts too much pressure.
Yeah, it's silly. And it defeats the organic nature of this discourse and dialogue. But what about this? What about the 1968 or 58 to 62 ish? How the Soviet Union and the United States just suddenly started sending up nuclear missiles and detonating them at high altitudes. Some people believe that, understanding the dome nature of our reality, that they called it Operation Fishbowl, by the way. The United States did, at least. And they detonated all of these nuclear bombs. Some people think they were trying to break the firmament or see if that were even possible. And it's at the same time that I believe that Van Allen was measuring the radiation that was accumulating. I mean, this wasn't like one day they went out and shot some missiles. They did this for years, again and again and again. And I think it was his job to measure the radiation that accumulated from these weapons being detonated up there, and that accumulation of radiation got attributed to him, and they call it the Van Allen radiation belt, and they've just inserted it into their science fiction narrative of reality that I believe that is being imposed on us. That's something to think about. So I don't want to answer or nothing. Yeah, that's interesting.
I'll look into that. So then I guess my parting shot would be the double sunset. It is possible to watch the sunset twice in the same day. If you go to the base of a tall tower, such as the Burj Khalifa in Dubai, you can observe the sunset, then take the elevator to the highest floor, and you can watch it set again.
Refraction. All right, I don't know.
I don't know. It shows the curvature.
Well, I'm glad it shows up there. That's something to be considered. I'll have to look into that too.
Okay.
Because that would have implications if that were true. So, all right. Hopefully, pretty soon we'll have another conversation. And thanks for watching, if you actually did.